Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, today we're fully live and we are going to show you the following topic: exchanging OCS data with Ignition using MQTT Sparkplug. So Ignition from Inductive Automation is a web SCADA program that is really hot lately. I mean, it's everywhere. A lot of OCS users are also interested in connecting to it. And the Horner OCS, it's hot as well. Our number of new customers, our sales, everything has been increasing terrifically. It's been very exciting. And for those of you who aren't familiar with Horner OCS, that's our brand name for our all-in-one controllers. And an all-in-one controller is, you can think of it as a highly capable PLC with a built-in HMI, all kinds of local and remote I/O options, as well as great capabilities of communication. So a very flexible component, to be sure. So today is all about getting that Horner OCS to communicate with Ignition from Inductive Automation using a new protocol that people are talking about, and that is MQTT. All right. So I'm going to present today's topic, and while I'm doing that, we've got folks standing by to answer any questions you have in the chat section if you're watching live, or in the comment section if you're watching on replay. All right, so let's take a look at how we're breaking down today's topic. Okay, we're going to start with an overview of today's demonstration. What are we trying to show? And then we're going to do a quick review of MQTT Sparkplug, which is the protocol we're going to be using, and it's different from the types of industrial protocols that a lot of us are used to, so we need to provide some additional information there. We're also going to review the system components involved in the communications chain, and we're going to do a step-by-step demonstration. All right, let's get started. Okay, so today's demonstration looks like this. First of all, we're going to publish data from an OCS on my bench that is performing machine control. And in my demonstration today, I think I'm doing pump control. And then what we want to do is we want to take this data that we're publishing from the OCS, and we want to display it on a web SCADA program called Ignition. Now, one of the great things about this is we're going to be able to auto-discover the data that we're going to be publishing from the OCS. We're not going to have to manually type in any of the variables or any of the tag names or any of those sorts of things. So we're going to be able to discover those tags automatically just by browsing, and we're going to be able to read and write data, again, just by browsing. Now, what makes it different, in addition to kind of the auto-discovery of the browser, auto-discovering of the tags, is that instead of Ignition pulling data from the OCS using one of the traditional pull response protocols like Modbus TCP, for instance, the OCS instead is going to be pushing the data using MQTT Sparkplug. So that's really what's different from a communication standpoint. So let's do our quick review of MQTT, starting with MQTT in general. Well, MQTT is a lightweight protocol. What does lightweight mean? Well, it's a protocol that doesn't take a large processor or a lot of horsepower or a lot of power to run. So that means it can be used in very, I guess you could say, devices that maybe are battery operated. It can be used in that environment. It also can be used in devices that maybe, aren't very powerful in general. Now, one of the reasons why MQTT is increasing in popularity is because of the increase in machine connectivity these days called Industry 4.0 or the Industrial Internet of Things. Now, one of the things about MQTT that makes it different is that it uses a publish-subscribe model. Again, different from what we're used to, and we'll talk about that in detail in a minute. And like a lot of protocols and standards these days, it started out as a proprietary protocol, some 25 years ago nearly. Okay, so the way MQTT works that makes it different than some of our standard industrial protocols is that, again, it uses a publisher-subscriber model instead of client-server. And protocols like Modbus TCP, for instance, use a client-server approach. So with publishers and subscribers, they don't directly talk to each other like they would with client server. Instead, they talk to a device called a broker. So independently, the publisher will publish data to the broker, and independently, a subscriber will also communicate with the broker. Now, the data that is published is called topics, and that data is published at a rate that's appropriate for the application. So if I'm an OCS doing pump control, maybe I have data I want to report once per second. Maybe I have data I want to report once an hour or once a minute, or maybe it's data that I only want to report when it changes. So depending on what's appropriate for that application, I can publish it at the appropriate rate. Now, the way this works from a broker standpoint is that all the data that is published by the publisher is maintained by the broker. And then as subscribers or other devices that are interested in receiving that published information, they can also communicate with the broker and basically express their interest in that topic data. And one of the great things about this is that it scales up very well. So instead of a client-server approach where a single client will need to talk to every server, in this scenario, the publishers and subscribers are disconnected. They can talk to one or more brokers, and you can really scale things up well. Now, what is MQTT Sparkplug? Now, so far, we've just talked about MQTT in general. Well, MQTT is a lightweight protocol, and one of the ways it's lightweight is that it doesn't define every element of the protocol. And so there's some things that you really need to add to that protocol in order to make it completely applicable to real-time industrial applications which are mission critical. So it's really designed to take the best of generic MQTT and add the extra information to the specification that really makes it great for those industrial applications. So some of the gaps that are filled in by Sparkplug include state management, so that a subscriber to data always knows that the data it's receiving from the broker is current and that the publisher of that data hasn't gone down and the data it's looking at isn't, invalid, for instance. Also, Sparkplug defines payload because MQTT in general doesn't specify what data is sent nor how is it formatted. So MQTT Sparkplug takes care of that. It also talks about how topics are organized by providing a hierarchy and a set of rules there. And it also adds what's required so that you can auto-discover variables or auto-discover tags, which is really powerful. Okay, now the components involved in a Sparkplug system are as follows. First of all, you have something called an MQTT edge node. So in our case, we've got an OCS that is going to be acting, if you will, as the edge node. So the OCS acts as that piece of hardware that's directly connected to the MQTT infrastructure, and effectively, it's publishing the data. That's what the OCS is going to do. And then, of course, the MQTT broker that we talked about, sometimes also called a server or distributor, it's the component that handles all the communications. And then with MQTT Sparkplug, you also have something called an MQTT host, typically a SCADA package, like Ignition that we're going to be showing today. And it publishes and subscribes to messages like an edge node would. But it also is responsible for the SCADA type functionality, and it also enables data that is published by an edge node like an OCS to not only be read by the SCADA program or the host device, but also to be turned around and written back to the edge node. So as an example, if you had the OCS reporting, let's say, a set point for temperature, for instance, for temperature control, the SCADA, the web SCADA, or the host would be interested in seeing what the current set point is, but it also might be interested in changing that set point through SCADA and sending it back down through the communications route back to the OCS. So with a host node with Sparkplug, that functionality can happen. You get the bi-directional capability we're all used to with protocols like Modbus TCP, for instance. And then finally, you also have MQTT application nodes. Those are the three on the left of the diagram there. Those are other software packages such as Historians or MES or Analytics that are interested in the data that's being published and that's available at the broker. And they're going to use those maybe for historical purpose, analytic type purposes, what have you. So those are the different components in a typical Sparkplug system. Now, in our specific Sparkplug system today, we're going to have the following three components. So our broker is going to be a broker called Chariot, okay? And this is available from a company called Cirrus. The MQTT host, or the web SCADA, is going to be Ignition from Inductive Automation, and the MQTT edge node is going to be one of our Horner OCS controllers that is publishing the data from its control system. Now, the specific versions of software that I'm using today, it's always helpful when somebody does a demonstration for you to understand specifically what versions were being shown. So in the case of inductive automation, my demonstration is using version 8.1.2 for Windows, and that's available from the Inductive Automation website. Now, that doesn't happen to be the latest version, although I don't think there'd be any problem in downloading the very latest version. Now, next we have the MQTT broker we're using, which is sometimes called a server and is sometimes called a distributor. Now, this distributor is available from Cirrus Link, and actually what's convenient about this particular one is you can download it right from the Inductive Automation website. So you go to inductiveautomation.com, you download Ignition, and then right from that same website, you can go ahead and download the MQTT distributor or broker that you can use for your testing. Now, the specific version you do need to download, this is important, you can't just download the latest, is 4.0.13. That's because there's been some changes made to the MQTT specification very recently, and we haven't adopted those quite yet at Horner. So you need to use version 4.0.13 as of November of 2023. Now, the very last thing from a component standpoint, software component you need to download, is what's called an MQTT engine. And this is a piece of software that Cirrus Link did that effectively is a module that allows the Inductive Automation Web SCADA package to interface to the broker. So that's what that's all about. So those are the specific versions of software we're using there. And then on the Horner side, I'm just using an EXLW Model 2, 7-inch model. I'm not using the 4-inch we're showing there on the screen. I'm using what I think is the latest firmware of 15.64 and the latest version of Seascape as of this video, which is Service Pack 10 from Seascape 9.9. Now, also, my controller has been licensed for MQTT Sparkplug. That's because to support MQTT Sparkplug, there's a one-time upgrade fee in the form of a license that you can do in the field. So I licensed my unit here in the field. You can do the same in the field as well. Now, this is not expensive. It's a one-time upgrade with no recurring cost of about $50 for this one-time upgrade to support Sparkplug. Just to be clear, not all Horner OCS models support Sparkplug, okay? So the ones that do include the X5 OCS, most of the XL series OCS from the XL4 on up, all the XL Prime series models, and then all future Canvas models all include support for Sparkplug. Now, if you are interested in testing this out and you would like to get a free copy of the MQTT license, then just use the comment section of this video before the end of this month, so before December 1st, 2023, and we'll send you a voucher for a free license for your OCS controller. And of course, make sure that your OCS controller is on the list to the left there. Okay, so without further ado, let's just dive right into showing you how to set everything up, and let's show it all in action. We've got a fully live demo for you today. What could possibly go wrong? All right, let's start out by taking a look at Inductive Automation's Ignition project, or product, I should say. All right, so I'm gonna go up here to Home, so we're all starting from the same location here. And this is the full version of Ignition, the commercial version of Ignition. And one of the great things about Ignition is that you can run it in trial mode, and it'll run for 2 hours. You can do all your testing, and then when you're done with your testing and you need to rerun it again, you can do that. And of course, you don't have to have a license in order to run it in trial mode. So that makes it really convenient. Okay, so let's talk about downloads first. Well, you would just go to the Inductive Automation website, download Ignition, and then go to the archive section of their download section, and that's where you can find the MQTT distributor and MQTT engine that you need. So I'm gonna go here to Config. I'm going to go under Modules. All right, now I've already installed Ignition. That's what we're working with here. They call it the Ignition Gateway, but it's basically Ignition, and we're accessing it via a web browser. And when we click on Modules, these are all the modules that have been installed in the Gateway software. And down here, we're showing that we've already installed the MQTT distributor. That's just another name for an MQTT broker or server. And we've also downloaded and installed the MQTT engine. Both of these components are from Cirrus Link Solutions. Both of these components were downloadable right from the Inductive Automation website. And specifically for these components, we needed to download version 4.0.13. That's the newest one that's supported by Horner OCS. Okay, so once we've installed Ignition and then we've downloaded and installed the distributor and the engine, now we're ready to do configuration. Okay, so let's go back to the top. All right, and this time, again, under config, I'm going to scroll down until I see MQTT distributor. So this is where we configure the settings for the broker, because remember, another name for broker is distributor. Okay, and nearly all of these settings are the defaults. I think I may have had to click this checkbox to enable the server. That was just about the only thing I really had to change here. I'm using a non-encrypted connection to the server. Now, you could choose to use an encrypted connection, but my demonstration today is going to be non-encrypted. So these are all default settings. Okay, I didn't do anything under TLS. I didn't do anything under advanced properties. Okay, and then users, this is where the user credentials are configured. So every edge node, and the OCS is an edge node, or any host device, and Ignition is a host device, will need to log in to the broker, or the distributor as they call it. And there's a default set of credentials already available. So the username is admin. Just so happens the password by default is ChangeMe, all one word, CHANGEME. And it's showing us here that there is read-write access to all topics through this login. So I didn't change anything here as well. So this is all the connections, all the configuration, I should say, that's required for the MQTT distributor, also known as a broker. All right, now let's scroll down further and let's find where we can change our settings as needed for the MQTT engine. So this is the module that has been installed so that Ignition, the web SCADA program, can talk to the MQTT broker or MQTT distributor. All right, so let's go to settings here. All right, so under general, again, most of what I've done here is completely default. I think I had to enable the MQTT engine, though I don't think that was checked by default. Everything else has more or less been default, except under command settings for block outbound edge node and block outbound device tag, I've unchecked those two boxes. So what that does for me is it allows any data that Ignition can see, okay, any topics that come in, any published data that comes in, for that data to be able to be turned around and written back to the OCS or whatever device was publishing it. So, which is very important for SCADA, right? If you've got a set point, sometimes it's set on the local PLC level, sometimes it's set at the SCADA level, and you want both to be supported. So I unchecked those two boxes. And then I think the last thing that I did, oh, here we go, right up here, is I entered in a primary host ID. Now, a primary host ID needs to be entered if you're ever going to have redundant brokers. So redundant brokers is where you might have multiple brokers running. So if one broker goes down or the connection to that broker has been broken, then edge nodes have the ability to log into a different broker so that communications can resume quickly. But in order for that to work, a primary host ID has to be typed in here, which I have done, and I've just called it Chariot. And then on the OCS side, when I show you that in a few minutes, you'll see that I've also typed in the primary host ID on the OCS side as well, so the OCS knows what that is. All right, now let's go to servers. And here it's showing that, yep, here's the MQTT server or distributor and the username that we're logged in at, and we're connected. So the MQTT engine for Ignition is connected to the broker or the distributor using this username. And this URL is the connection that's being made. Now, the reason this isn't a traditional IP address is because both the broker piece and the Ignition piece are residing on the same PC. So therefore, the connection address, if you will, between the MQTT engine for Ignition and the broker is just through the local computer, through the local host. So that's a special address you can use for that. Okay, and down here it's telling us that our device tags and node tags are not blocked so that we can read and write data if necessary. If you're setting this up and it shows they are blocked, it means you forgot to uncheck those two check marks I talked about earlier that can block the read-write access. Okay, so that's the setup there, and everything is looking good. So Ignition can talk to the broker just fine. Now we need to make sure that the OCS can talk to the broker just fine. So let's move over to Cscape, and let's set up Cscape so that we can publish our data, the data that we want to ultimately end up at Ignition. Now, before I dive into the Seascape setup here, let me just show you what we have going on the bench. And here is my demo system I have here. I'm simulating a pump control system. So we're going to want to report data to the web SCADA, which is Ignition. We're going to use MQTT to do that. And some of the data we're going to report is going to be our water pressure, our pump auto set points, whether the pump's in auto or hand mode, those sorts of things. Those are going to be what we're going to effectively send up to the web SCADA package. So let's go configure that right now in Seascape. All right, so I'm not going to show you into my ladder logic. That's just doing some simple pump control demonstrations. Let's dive right into the MQTT configuration, which we can access through Program and Messaging and MQTT. All right, so this is a 4-level configuration dialog. Now, the only profile we're currently supporting for MQTT is Sparkplug, so nothing to configure here. And then here's what we have to configure under the Controller tab. All right, so we start with a status register. We need to know that we're successfully communicating with the broker, right? That's important information. So there is 52 words of status data, all integers. And so I've created a variable called MQTT status, which is an integer array of 52 values. So this is the first element, or the first member of that array is MQTT status with an index of 0. Now I've also assigned a variable that is a Boolean type that when it's turned on will enable MQTT communications from the OCS. So that's another variable I had to create and also, list here. Now, client ID. What is client ID? Client ID should be a completely unique identifier for any node that's reporting data. Now, one way to ensure we have a completely unique identifier is to use the MAC address, the Ethernet MAC address for the OCS that's reporting the data. And because client ID is a text or ASCII type field, we're going to put that MAC address in between single quotes, and therefore this client ID is going to be reported, and it will be guaranteed to be completely unique and not match some other node, because every MAC address by definition must be unique. All right, next let's move down here. What is group ID? Okay, so these are the things we're going to configure that are going to basically kind of help organize our data that we're reporting. So group ID is a convenient textual name that you give to the group of nodes that are reporting data to the broker. So it could be your company name, it could be a site name or a plant name, it could be a geographic name. In my case, I just named it Horner because I'm going to say that all of the Horner nodes reporting data, or all the nodes that are reporting data, are all belonging to the Horner group. So that's my group ID. And this comes into play when we start browsing for tags or browsing for variables from Ignition. Next, we have node ID. What kind of textual name do I want to give this specific node that's reporting data? I'm doing pump control here. I'm going to call this pump control. And then this is where we type in that primary host ID so that if we're going to support redundancy of brokers, that will work. So I've typed in Chariot here, just like I did under the MQTT engine configuration. Okay, so this is my configuration on the controller level for MQTT. Now, next, we need to configure the connection to the broker because we've got to be able to log into the broker. And so we need user credentials and more settings. So I'll go to edit here so we can take a look at this. Okay, this is just a convenient name. It doesn't go out over the wire. I'm calling this the Ignition broker just so I remember what it is a few months from now when I go back and look at this configuration. Next is the IP address. Could also be a URL if that's what you had, but this is the IP address for the broker. So my computer that's on the network that's running Ignition and the broker happens to be this particular IP address on the local network. Now, I mentioned earlier, this demo is unencrypted. So here's the standard port number for unencrypted MQTT. Here's those default credentials for the MQT distributor/broker/server, which was admin lowercase and change me. Now, of course, in a real application, you're going to add multiple users. You're going to give individual usernames and passwords, but we're just using the default right now. Now, what is keep alive? Well, one of the things that Sparkplug does is it defines a way that subscribers to data can know that the publishers of data may be down or that the data that they're looking at is invalid. So the way that would happen is, one of the ways that happens is through a keep alive. So as the OCS that's publishing data to the broker, I'm going to be sending data periodically, and we haven't decided what data yet, but we'll cover that in a minute. However, I may not be publishing data all that frequently because maybe the data hasn't changed, or maybe it's data I'm not reporting a lot. So I'm going to configure a keep alive so that I'll send a signal to the broker saying, hey, I may not have sent you any data lately, but I'm still good. So you can be assured that all the data you've got from me is the latest and the greatest. So that's what the keep alive is. And then clean session needs to be checked. I won't explain exactly what it is, but it needs to be checked for Sparkplug. And that's all the configuration that's needed on the broker side of things, or to communicate with the broker. Now, if this was an encrypted setting or an encrypted demo, I would have to configure this page here, and I would use a different port and all that sort of thing. But again, this demonstration is unencrypted. All right, so that is the broker connection. And then finally, we have to decide what data are we actually going to be publishing, by what topic names are we going to be using for that data, and then how often are we going to be publishing that data. So let's move to the topic configuration next. And here we have a list of all the topics that have previously been configured. So let's go in and take a look at the detail for this topic. So again, topics are how data is organized within MQTT Sparkplug. So I've created a topic, which you can think of as a category or even like a folder, that all my different variables or tags are going to reside under and be organized under, and when they're being sent to Ignition, and then when Ignition is browsing for these particular variables. So I've called them pump because that makes logical sense. So if a subscriber subscribes to the pump data, they're going to get all of these metrics or all of these variables, including if the water pump's running or not, if the pump's in automatic or not, what's the current tank level, what's the pressure, what are my set points, all those sorts of things. So this is all the variables that are included in the pump topic. So anybody that subscribes to the pump topic is going to get all this data. Now, quality of service, what is that? Well, one of the great things about MQTT is you can kind of set up independent handshaking, if you will. So you can have as much handshaking or as little handshaking as you want to use when an edge device like an OCS is publishing data to a broker. Let me give you some reasons why you may not always want the same level of handshaking. So if you've got a really, really good connection, very reliable, and you're sending data very frequently, you might use something called quality of service, or QoS 0. This means that I'm going to publish this data, I'm going to send out this message with this data to the broker, and if he doesn't receive it, I don't care because I've got another transmission I'm going to be making shortly. So in that scenario, there's literally no handshaking that's done in the message exchange, and I've chosen quality of service 0. Now with quality of service 1, maybe my connectivity isn't quite as good, or maybe I want a little more assurance that the data's been received properly. So with quality of service 1, I can be assured that the data will be received at least once. Now it could go out more than once, but it'll be received at least once. Now quality of service 2 requires the most handshaking, and that's handshaking that requires that the data will only be received by the broker exactly once. And I would only use quality of service 2 if I have sequential data being sent, and if the broker received duplicates of the same data, that would be a problem. So I typically will default to quality of service 1 and adjust from there. And then down here, this is how often are we sending the data. For my demonstration, I'm sending it once per second. Okay, so that should be the configuration for everything. Now let's see if we can exchange some data, if we can browse some tags. Let's see if we can make it all work. All right, so I'm going to go back to my bench view here and take a look at the OCS. Now in the lower left-hand corner, that's where I can turn on that MQTT enable/disable bit. So let me turn that on. Okay, good news. Our status is 15. So there are 4 bits in that first status word for MQTT status. And if each of them are on, it means everything's good. Our configuration is valid. Everything's good. We're communicating with the broker. So now that we're communicating with the broker, everything looks good from the OCS side. All right, now let's go back to our computer and let's take a look at how things look on the Ignition side, on the Web SCADA Ignition side. All right, so this is my project for Ignition. Now I have put absolutely nothing on here yet. There's no objects, there's no user interface going on. All I've got is an area I could add objects to for visualization purposes. And over here, I have a tag browser where I can browse for any tags that are available for me to use in my project. So under the tag browser, I've highlighted, in this case, let's go ahead and take a look at the MQTT engine. all right, because this is where the MQTT data would come in. And under edge nodes, what do we find under edge nodes? Well, there's Horner as an edge node. Well, that was the group ID. So there's our group of edge nodes, Horner, available to us. And if we drill down even further, now we can see pump control. Well, pump control was the node ID from the OCS that's transmitting the data. And if there were multiple OCS nodes in the Horner group ID, then we would see them all on the same level. Now, as I drill down under pump control, I get node control, node info, and then down here, I get all my topics. And remember, we only had one topic and it was called pump. And underneath that, we have, here's where all of our metrics or all of our variables are showing up. And look, I didn't have to configure anything. I'm looking at live water pressure. I'm looking at my on and off set points. My pump isn't automatic. My water pump is not currently running. And I didn't have to type in any of that information. So that's very cool. The tag browsing is very powerful. Okay, so if I want to take the pump out of automatic, I should be able to uncheck this box here, which should take my pump out of automatic. And if I go back and take a look at what things are going on the bench, I can see, sure enough, in the upper left-hand corner, my pump mode is not automatic, it's hand mode. All right, very good. Now, if I want to adjust my set points, I can do that. All right, so let's go back to ignition. And let's change our on set point from 58 to, let's make it 65. There we go. And if we go back to our benchtop view, we can see, yep, sure enough, our on set point in the lower center there has changed to 65. So everything's working beautifully. We're publishing data from the OCS to the broker. Both the OCS and ignition are talking to the broker. They're exchanging data, and the data is two-directional because of the fact that ignition is acting as the host device, and the data that the OCS publishing can therefore be written back to the OCS. All right, very cool. All right, let's go ahead, and that pretty much wraps up the information I wanted to share with you today. Let's go ahead and wrap up our session. All right, this is where I remind you that every Tuesday at 2 o'clock, we're here on YouTube, whether we're fully live like today, with a completely live demonstration, I might add, or whether we are pre-recorded or partially pre-recorded. We do it all kinds of different ways here at Horner, but be aware that almost every Tuesday, I think it's been every one this year so far, we're here at 2 o'clock with somebody standing by to answer any questions you might have in the chat section if you're watching live, and we're always ready to respond to comments in the comment section if you're watching things on replay. Now, we're celebrating 10 years of the Horner Lighting Group this year. Don't hesitate to go to the Horner APG YouTube channel. We've got great automation video content. We've got great lighting content, all available on the same Horner YouTube channel. Now, we're done with training for 2023 because we're coming up on the holiday season. We just finished up our last advanced course last week, which I had the honor of teaching that course. We had a great course of 7 students going through the advanced stuff. A great class for sure, very knowledgeable. We went out and we went bowling and had a great meal on Tuesday night. It was just a fun week. So sign up for a great week sometime in 2024. Now, we haven't posted the schedule yet, but it will be coming up on our website, a place for you to sign up, and just be prepared for either standard training, advanced training, IEC training. It's all going to be available in 2024. Okay, next week, we're going to be exploring the connection of the Horner OCS with some servo systems from Infranor. So I get a lot of requests for, how do I connect to this servo system? How do I connect to that servo system? And the folks from Infranor are kind enough to have not only loaned me equipment, but they're also going to join me as we go through the demonstration of making the connection between Horner OCS and Infranor servo system. So join us next week, same bat time, same bat channel. Okay, if you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, when we bring the folks in from Infranor and we explore the connection of servo systems with the Horner OCS, let's all get out there and do us some good.